Professor Michael Fox, he has lectured, his practice and teaching and research are centered on interactive architecture with a secondary focus on the architecture for outer space and has carried out several projects for NASA. Fox is the past founder and director of Kinetic Design Group at MIT. He has lectured internationally on the subject matter of interactive, behavioral, and kinetic architecture. He has won various awards in architectural idea competitions. Fox's works has been featured in numerous international periodical and books and has been exhibited worldwide, including San Francisco MoMA and the Venice Biennale and the Smithsonian Air and Space Museum and so on. And his work has been funded by NASA, the Amsberg Foundation, the National Space Grant Foundation, and so on. Okay, let's welcome Professor Michael Fox.
Okay, yeah. Well, thank you so much for having me. It's a pleasure. I wish I could be there in person. I love Tsinghua. I spent a summer there when I was in school as a student, and I always remember it every time I go back. Maybe I'll just share a screen and is that working now? Yes.
And we can see you.
You can see it okay?
Yeah, it's okay.
Okay. And so let me see where the volume is. So I'm gonna talk a bit about interactive horizons. I think it's interesting. There's a few of us, you know, that you have gathered, Philip and myself, Rory, Glenn, been doing this and interested in this idea of interactive architecture for a long time. And I'm very interested in kind of the horizons and the trajectories always. Looking at things like technology transfer and interface design, autonomous robotics, mechanics, and biomimetics, and evolutionary systems, all of these kind of areas that are related to what interactive architecture is or what it can be. I think there's lots of times two diametrically opposed perspectives to interaction design and interactive architecture, and one is that's, you know, a life defined by convenience, and the other is that of a life controlled by the machine. And I think today we've come to embrace basically every new technology with the promise of convenience, and I think this is lots of times illusionary. But for the most part, we've given up on the fear, and all you have to do is look at the kind of way younger people interact with technologies is very different than the way older people interact with technologies, and everything is embraced very easily. And I think we need to question things, and in particular, I think we need to question ethics. There's a lot of issues of privacy that bother me a lot, and in adaptive control, I think, you know, we have to look at how it changes our behaviors. Sometimes good, sometimes bad. Do we have cognitive atrophies? I have lots of examples of these kind of cognitive atrophies that I think about, you know, of our inability to memorize strings of numbers, of our ways of interacting with a lot of technologies that have made us really rely on the technologies, of how we drive somewhere with GPS, and we forget to look around and make a mental map of our urban environment. And there's a lot of these ways that we use technologies that may provide convenience, but at the same time, simultaneously, cause different cognitive atrophies. And so I think we need to sometimes question that just because it's possible doesn't necessarily mean that it's a good idea. And I'm guilty of this a lot. As kind of an artist and a researcher. And I'm going to talk about two kind of areas here initially. One is kind of pragmatic, and that's dealing with these very pragmatic things in architecture, adaptability and optimization. And the second is humanistic. And I've kind of divided things into these categories. And with the humanistic, we're dealing with things like sociology and psychology and human behaviors, how we sense place, how we understand space, how we can have an attachment to space and bond to space. And so I'm going to begin with the humanistic stuff. And I think, done a lot of different kind of projects, and most of these fall within the realm of art, and they're very exploratory. And I'll just kind of start with this first one, which was an exhibit we did a long, long time ago in Los Angeles, which was these bubbles. And the idea was to make a bunch of bubbles that completely saturated the space. And then as you moved around the space and you were with clusters of people, the space would make a room for you. And it would open up and surround you with walls. And as you move to a different place, the walls would sort of change. And this is an actual section. There were a lot of these. And it was interactive with the kind of social agenda of making space out of a totally saturated environment. And it was very tactile and spatial, and beauty had a part of it. This next one was kind of the same idea of making space. And the idea is, you have this kind of wall of things, and as you pass through it, they move out of your way, and they're lit up at night, and they kind of make these really nice patterns. But that it's a wall that sort of transforms and basically recognizes you and moves out of the way for you to pass through. And this third one, and I'm just kind of breezing through a lot of these because there's a lot of these different projects that kind of touch on the same ideas in terms of social interactions. And with this one, basically, as you, this is at Coachella Music Festival, and basically, as you pass by one of the legs and another person comes in contact with one of the legs, then the lights kind of move throughout the structure and connect you to the other person. So you look up and you look over and you recognize another person that you might not. So it's kind of pushing people towards interacting with each other. And this was just a design for another one of those in a public space that may or may not get built. So this, and I'm not showing a lot of movies because I'd rather try and tie all these projects together. But this next project, this is in Hong Kong, and this is in the Zaha building. This was done with students, and it was to hang all of these bubbles as a way of signifying the activity in the building. And it's a beautiful building by Zaha, and it's not, it was kind of a critique on the building of Zaha, but the idea was that nobody's really aware of what anybody else is doing. And this is in a design school. But you walk in and everybody goes straight to the elevator and up to the floor that you're on, and you go into the classroom that you're in, and you're not aware of all the other activity that's going on within the building. So this was a way to visualize the activity that's going on. And I'll turn the volume down a bit. But you see these differing experiments that they were looking at. And And so if there's work going on in a particular studio, then each one of these bubbles are wired up, are connected to a studio environment. And otherwise, you're simply not aware that you walk through an empty lobby and you're not aware of any of the activity that's going on in the different classrooms. So um, this was another one in the same building that also dealt with community awareness within this space, because to a large extent, everyone sort of walks past each other in this lobby on their way to the elevator. And the idea was to make something as a kind of piece that allowed people to pass by and be aware of the other people. So to make the wall activate, there has to be two people participating at one on each side. So with all of these projects, there's kind of this idea about social interaction and social participation that comes after really observing how people are interacting with the space and seeing how the environment can change these interactions. Then, an interesting part is after while the project is installed, that the students analyze and record how people, unsolicited people, actually interact with the work, and kind of make an analysis report on whether or not the project is working, I guess, whether it's engaging people, whether it's provoking people to engage with each other. And so with that said, there's something beyond social interaction that just has to do with play. And I wanted to put this project in. And it's just a simple wall. But and I always like that project because it really works. Every time somebody walks by and the wall would engage with them by making something that really was provocative in such a really simple way. And people try and put it back in and fix it. And then they become engaged with trying to fix this wall that continually unravels in front of them. And, eventually they typically give up and sometimes they solve the problem. But that it really did work to engage people, which I think was the, the goal of the project. This is just a design of something that has we proposed for a project right before the pandemic, but then the pandemic came and I don't know what's going to happen with it, but it's a large sort of rubber ball that's very tactile and it's hooked to these cables, and then it can be pushed, manually pushed back and forth and up to an apex, and it's hooked to these cantilever strings on, like with counterweights on the back that make a pattern. But it's just another example of a very kind of playful sculptural item that deals with the tactility and collaboration, so that it takes several people to push this ball back and forth. And so, those are kind of the humanistic projects that are mostly dealing with these social interactions. And there's a lot, tons more that we've kind of explored. And I think the next group I want to kind of look at are these pragmatic things. And these are much more architectural. This was a project in Israel to make a wedding hall that could be like this, like a wedding hall, but could also have the ability to transform to something like this, or like this, or like this. And so we began kind of thinking about having a lot of differing motors that are set up, that are hooked to a large piece of fabric. And this was a prototype of the fabric coming together within the building. You can see it's quite large. It's kind of interesting to walk through it as it was going up. It was kind of this really interesting moonscape place. And here you see it under construction. So it was actually fairly heavy. There's a lot of tension on this fabric. And then as it was going together, I think that's a movie. Let me play it. So these are some finished images of it as the wedding hall. Here's this is up above. This is sort of when I was over there during the construction, right before it was completed. It really sort of breathes. And there's tracks in the ground so the bottom can move in basically any different configuration as it's being set up. These are just some finished images of it as it's set up as a wedding hall. And it also had really nice kind of projection mapping on the fabric as the fabric moves. So it could make a really nice sort of digital screen as well, which was one of the reasons why we chose to use the fabric, but it can really change the environment. So, in light of these very large kind of everything I've kind of shown so far are these very mechanical things, and done a lot of kind of work and research into robotics, which has, even in my time since I've been interested in this, the robotics have really changed from sort of, original large pick and place robotics to modular robotics to robotics getting smaller and smaller to even soft robotics. And, we're always asking, what are the architectural implications of this as robotics being used within within architecture, and you kind of see the scale of these robotics, and that they can actually, start to have a sense of materiality, a sense of softness versus hardness. And um, this was something we did as a sort of a projection screen that we worked on a while ago that also has an interaction built into it. And we sort of learned a lot exploring this project. And with this other project, this is called Nano City, but it's just a theoretical project. But the idea is, how something can kind of appear out of nowhere, and this is using ferrofluid with these magnets that ride underneath it. And the idea of this is kind of looking at robotics at a scale where things can kind of disappear or reappear, and what are the architectural implications. This was another exhibit that we did looking at this idea of nano city, of basically an entire city being made of nanoscale robotics, that basically, with this project, there's robotics on one side that eat away at the city, and there's robots on the other side that rebuild the city. And so in a sense, as the topography moves around, the city is essentially moving across the landscape, and it can stay pretty much the same, but it's changing the base materials that the urban fabric is made of. And so I want to talk a bit about, catalyst design. In other words, that with interaction design, and a lot of what we do is not necessarily to make a finished thing, but to make something that can evolve. And it's not so much to design a finished product, but to catalyze it. And I show the phone because the phone is extraordinarily popular, but it's not because it's a good thing to talk with people voice to voice, but it's popular because it became a platform for everybody to contribute to, for people to design. And the phone has evolved, and the way that people use the phone has evolved. And really the idea that it's a phone is very much secondary to the idea that it's a home for apps that people build, apps that other people use, apps that are in demand by people. And it's endlessly evolving in this respect. And in sort of thinking of this idea of catalyst design, of design that can evolve, we've sort of been looking at gestures as a way of controlling the environment, because there's a lot of different ways that we use gestures for different things, and how we can control our environment as not something we sort of dictate as the designers, but something that people develop on their own, and something that's a natural way. So that design is really more of an egoless emergent endeavor, not so much, again, designing the future, but designing some sort of platform for the future. And to test this idea, we set up a room. I don't have this movie, I don't think. I didn't put it in. But we set up this room where you can control the doors, and you can control all the windows, different things, through simply using gestural control. And what we found is that it was very difficult because people had different gestures for different things. So if I tell my kid to come here, I'm probably going to use this gesture. And if likely somebody in Beijing told their kid to come here, they would likely use this gesture, a completely different gesture. And there's so much entangled in these gestures that has to do with culture, that has to do with habit, that has to do with, different societies. And that what we learned is that we needed to make a system that could learn different behaviors from the people, So if I wanted to open a door, I would make my own gesture and the system would learn my gesture to open the door. And so I wanted to show this project. This is by, oh, I don't have the movie here, but this is um, Benaz, who is quite famous now in her clothing that she makes in terms of interaction design, and she's stuck with this. I was working with her on her thesis, which was to make this gesturally controlled wall, and it was a wall that the person dances with, and the wall can learn the dances of the person. And so kept on this theme a little bit further and started developing a number of these projects, mostly with students, of where you sort of learn how to operate something, and in an interactive way, and these are mostly with gestural control, but you learn to play it. It's almost like a piano, and I like this part of the movie, that you learn to manipulate it in different ways, and you learn how to play the architecture, almost as you would a musical instrument, and that it becomes very finely tuned to the way that any particular person would engage with it, as opposed to kind of being a generic sort of response. With this, we made a sort of exploration into music, and this is with students. I'm probably going to turn up the volume on this one. And so as the more you engage with the project, the more you get out of it, and it basically teaches you the music in an interactive way, and you begin sort of with a few notes, and then you understand the next note, and eventually when you get it right, then it kind of teaches you the whole song. So it's an instrument that comes alive with the learning component, and it's also architectural. It's at an architectural scale. So it's it kind of led to this next project that's also about sound and engaging people in interacting with it in an acoustic way. This is also at PolyU in Hong Kong. So it has this breathing motion as you walk by. So as you press on that, this is actual sound of her interacting with the fabric, and it changes the sound. These guys got pretty good at actually composing the fabric. But the the point behind these projects, and remember I said the earlier projects were about sort of social interactions, and with this project, for instance, it was about, you know, they had the choice that they could make something that was either sociopedal or sociofugal, that they had to sort of, the goal of the project was to change behaviors in a way that either could bring people together and make them interact, or one that could facilitate people's privacy and ability to kind of not interact with people. And I think both were important. And the point was to kind of understand how both of these simultaneously exist in a lot of public spaces and the role that architecture can play in these. So this project I'm going to show, but it's still in construction. And this is with a good friend, Axel Killian, who we've done lots of projects with. He also worked on the early project Bubbles. And this is a clock. This is in Guangzhou. The idea with this is it's called a sketch in time. And it was to, the idea was to look at time and how time can be interrupted and frozen, and that it can leave a sketch in time that's temporal, that can disappear. And we looked at lots of ways of how we could communicate this idea of time in the space. And the idea here is to make something that could, you know, write on the wall and then slowly over time disappear until the next hour. And so the idea is that, you know, first we had to figure out, I'm going to show a lot of process stuff here because this is kind of ongoing. But the idea here was first to sort of look at, you know, how we can make something that can mark on the wall. And then this is using UV paint with UV flashlight, and so the paint is on the wall, and then as the flashlight runs by, and this was the first kind of exploration. And then so is in this space within a building in Guangzhou, and we started looking at, you know, the first kind of prototype, simple one made out of wood, and then another one made out of metal. And using a double pendulum, this is like we just basically bolted it onto a deck in the driveway. And using a double pendulum, the pattern on the end is always unpredictable. And so the sketch would be always unpredictable. And the pathway that it makes, and that was kind of the main thing that we wanted to explore, is this unpredictable nature of the sketch. And so kind of did the first prototype there, and it seemed to work. And then we took it to Seattle, and this is the motorized version after we had it motorized and looking at different control of the arms, etc. And the idea is, so every half an hour, every hour on the half an hour, the clock drops. and it's slowly rising up across the wall, and it actually is a real clock that tells time throughout the day. But then every hour, once an hour, it makes a unique sketch that then disappears. And so you have a different sketch every hour that marks on the wall and then slowly disappears. And it rotates for about 10 minutes, just freely as it drops, making a unique sketch for quite a long time. This I just this is kind of the motor system that we then packaged up and had to ship there. And because of the pandemic, it had to be completely assembled by other people who have no idea what this strange sort of machine is, because there's really no instructions for such a device. And then, so we hung it on the wall, and this is still ongoing. We talked with them just last night, but it's getting close. So you can see it making the pattern on the wall. And we, these were the first efforts, and then we changed we just put on a new light on the bottom, which is much stronger, because the sketch is much too faint when it's moving quickly, and I think it can use another coat of this magic paint. But anyway, I want to, even though this is on progress, I want to share it. It's been really difficult putting together a project like this during a pandemic, and we can't even go there. So, it's pretty impressive that it was even put together by people there when it's during a pandemic. So it's getting close, and I hope to have a good final video soon. And so I just want to talk about architecture a bit, because all this stuff that I've shown so far is about interesting things dealing with social interactions, dealing with how people interact with each other, how they interact with the environment, how the environment can change the way people interact. But we've kind of forgotten the architecture in it. And I just want to say that, like, I'm an architect, and I spend probably half of my life making architecture. And we have an office with I do with my wife, and we explore a lot of things that are kinetic and moving and interacting, whether it's like doors or changing views. And I'm just kind of flipping through a lot of this architecture that we do. And there's a lot of projects under construction right now, which is kind of exciting. All of these projects that I'm showing are like finished or under construction. And I just sort of wanted to show that, because making this architecture, which is a huge part of my life, has made me sort of think differently about interaction design. It's made me sort of understand that architecture is a really important component of interactive architecture, and how stuff in these conferences, how stuff in the research world of academia makes it into real world architecture is important to me. And I think it's important to our planet. And so where I'm kind of going with this has led into this other area of extreme architecture. And I've done a lot of this work in sort of space architecture, meaning architecture for outer space. Done a lot with students at Cal Poly, and I think, this is the first one, which is a project which is was a habitat for deep space missions, and we built this prototype and sort of as a real world analog. So it's very low-fi materials, but the idea with this space architecture is really looking at sort of I think a vision for buildings in the future that can live on local resources. Designs with limited resources, such as those for extreme environments, leads to a much higher respect of nature. And in a way, this can be brought back to Earth. This was the next project that we did, similar related to that was a project sort of exploring these handhold footholds. And I think I don't have the movie here, but the idea was that, you know, there's these sensors on these handhold footholds on the spaceship. And that the interesting part about this project was that the digital model was hooked up to the live model. Oh, I should show a video of this. If I can. But we got to fly in zero gravity in space, which was a lot of fun. And I think it's always a successful project when you get to fly in zero gravity. So this next one is another similar habitat that we built. And this was for kind of a part of a habitat that could house people flying to Mars, but then also become the habitat once it is on Mars. And once it's on Mars, it unrolls to a different configuration. We did lots of explorations with students. This is with Cal Poly students. This is with, and I co-taught it with another professor, Mark Schulitz. Led a lot of it. So there were a lot of these kind of explorations in robotics, of how it could unroll, how it could open. And we made a full-scale prototype and then used AR with Microsoft glasses to have a AR environment, so we could deal with real-scale furniture and fittings and stuff like this. This was a VR model that we also made for just with the Oculus. So this is the sort of full-scale prototype that was integrated with the AR. And, you know, we went through lots of different explorations with the students early on of different types, et cetera. And this is what we kind of came up with was, you know, you have this sort of environment that's spherical in zero G as you're flying to Mars, and then it unrolls into a linear configuration of a habitat. And again, like I said, this is sort of the VR model, and this was the AR analog model. And the AR is actually really cool, where you can kind of get a full-scale understanding of the space that's superimposed on the physical artifact, which was really kind of crude. And so, you know, then we made a big, large scale prototype and took this out to the desert. We had some great help with that with people from Trimble, which is used to be Gary Technologies. It was kind of cool because it ended up going to the model and the movies at the San Francisco Museum of Modern Art, which was in a great space exhibit last summer. And I think the idea with these projects for outer space is looking at extreme. And the point is really to research what works and doesn't work in the extreme as what can be applied to regular architecture and real life applications to kind of bring it home. And this is another project that we're working on right now. And this is in the Atacama Desert in Chile. Went there to visit the site. It is known as the sort of most extreme area on the planet Earth. There's a number of extreme environments, but this one is really extreme in terms of being hot, in terms of being cold, in terms of some places in the desert have never had any recorded rainfall. Some places have had, like a few centimeters in 30 years. It's incredibly dry. There is life there, but it's very difficult for things to survive. And it is close to a major city, so it's a perfect spot for this extreme environment research habitat where they can do a lot of research for many months a year. So this is done with the university there, and we're working on the design. We sort of looked at the program of different sort of needs that they had. So there's a fabrication lab, a research area, and then there's habitation areas for 4 male and 4 female. So 2 different sort of habitation areas, and there's fitness area, and then food production. And the idea with this was also to look at, a geometry that could be expanded over time. So initially it's sort of one habitat, but how we could come up with something that could allow them to make more options and add to it over time was an important attribute of it. This is the plan that was finally resolved in terms of the lab and fabrication. Here we have sleeping quarters, the office and research, this is the fitness area, and the other sleeping quarters, and then the kitchen and sort of lounge. And that 8 people will live here for anywhere between 30 days and 60 days. And they're in this tiny environment, in that very, very extreme environment for a long period of time. The point is that it is as close to, being kind of completely off the grid as you can be. This is an exploded image of it. We also had to consider that each of these would be a separate module, and they're then taken up to the site, and then it gets assembled because you can't really do the construction there. This is just an image of it on the outside. So they're going to we're kind of working on detailed drawings now, but the idea is that they are going to start to construct the first one, which is this hexagon, next year. And here's some other images by Mark Martineau, who was a great former student who's been working on this project. And the idea with this is that there's energy generation with solar and with wind, and there's food production, and the whole center is this kind of hydroponics and aeroponics area that also contains water storage. There's recycling of septic in the leach field. There's it's basically a closed loop system. And in terms of construction, it's still dealing with a lot of these exploratory things in terms of materiality and kinetics and the transportation. And the robotics and control basically are there to necessitate everything kind of working together in terms of not just adapting to the environment, which is extreme, but adapting to the people who are living there in very close quarters. And I think all of the kind of social fugal kind of issues that come up with 8 people living together in a closed loop environment. so the people become part of that loop. So it's really kind of thinking about the interaction and the interactive architecture as a way of kind of controlling all of this and all of these systems. So anyway, I want to say thank you and thanks to the many students at CPP and at HKPU and people at the office of Fox Lin and my wife Drinta, who works on all of those architecture projects with us. Thank you.
Thank you, Professor Fox. Thank you for the